Now we'll discuss about the demodulation of FM waves. Here we followed two different steps in order to obtain the the message signal from frequency modulated wave. That is, first conversion of FM signal into AM signal whose output voltage is directly proportional to the input frequency what's applied in case of a frequency modulated wave. And the other thing is, when amplitude modulated wave is obtained, we'll demodulate it by using envelope detector. So by following these two steps, we can get the message signal and demodulation can be done. And demodulation can be done in two ways. One is by using slope detectors and the other by using phase difference discriminators. In case of slope detectors, we follow two different methods. One is single tune and the other is stagger tune. In case of phase difference methods, we follow two different methods. One is Foster-Siller method and the other is ratio detector method. Among all these methods, ratio detector method is most widely used than any other method. Now we'll discuss first method of demodulation, which is slope detection method. In case of slope detection method, this is single tune discriminator circuit, which is also called simple slope detector. Here, as we have already discussed about the two steps which are involved in demodulation, first is conversion part of FM into AM signal by using a discriminator. Here, a tuned circuit is involved whose output voltage is directly proportional to the input frequency what's given by frequency modulated wave. So output voltage in case of AM is directly proportional to the change in frequency. So from this, alpha is a constant which is given by the ratio of output voltage by input variation in frequency. So from here we are going to have an amplitude modulated wave. From here, when amplitude modulated wave is given to an envelope detector, we are going to have a message signal, which is nothing but the baseband signal which we have already given. So merits of this are it's simple and inexpensive, whereas it has many disadvantages and hence it's not used. First demerit is it has nonlinear characteristics, so it has harmonic distortions. And it doesn't eliminate amplitude variations. So because of these two drawbacks, it's not properly used. This is second method of demodulating wideband frequency modulated wave, which is balanced slope detector. Here we follow the first procedure, but here we have two different tuned circuits. One tuned circuit's frequency is greater than the initial frequency what we have applied, and this is less than what we have applied. So because of these two, we are going to have the output voltage as summation of first circuit and second circuit. So here we are going to have linear characteristics. Because of this linear characteristics, we don't have harmonic distortion. And slope is similar to what we have already discussed. Only advantage here is the use of two tuned circuits. Because of this, we don't have any harmonic distortion. And here, if the tuned circuit is not properly band limited, then this harmonic distortion may occur. So these tuned circuits should be properly resonated in order to have, eliminate this harmonic distortion. This type of discriminator, which is called Foster-Siller discriminator. This is most widely used and the circuit arrangement is as shown here. Here we use two diodes in addition to the previous method. And this capacitor, advantage of this capacitor is it blocks DC from primary to secondary, and the other advantage is it couples signal frequency from primary to center tapping of the secondary. So here whatever voltage present at the input will be present across this inductor. and there might be some leakage at this capacitor, but if you arrange this arrangement in such a way that L and C values are adjusted in order so that this drop across this capacitor can be neglected. So you have V3, which is input voltage here. We have two different diodes arranged here. So let this voltage across this part be VA1 and the voltage across this part be VA2. And after the diodes, let the voltage across this part be V01 and let the voltage across this part be V02. And the output voltage will be equal to the difference of these two voltages. And here, the center tapping of the secondary has an equal and opposite voltage across each halves. So therefore here V1 and V2 are equal in magnitude but opposite in phase. So we have an equation for VA1 as VA1 is equal to V1 plus V3, VA2 is equal to V2 plus V3. So depending upon the phasor relationship, we have three different phasor diagrams, and this will be decided depending upon the resonance. So here, if it is at resonance, there are three different conditions. One is resonance, at resonance. At this part, V1 and V2 voltages will be 90 degrees in phase with V1 and with V3. So here, if this is V3, we have VA1 and VA2. This is V1 and this is V2. So V1 and V2 are 90 degrees in phase relationship with V3. And the other case is off resonance. In off resonance, we have two different conditions that depends upon the frequency levels. When the input voltage is off the resonant frequency of the tuned secondary, then the phase position of V1 and V2 related to V3 will be different from 90 degrees. Here, if the input signal frequency is above resonant frequency, then the phase relationship between V3 and V1 will be 135 degrees. And this is shown like this. If this is V3, this is VA2 and this is VA1. This makes an angle 135 degrees and VA1 makes an angle 45 degrees. So here VA1 is less in magnitude when compared to VA2, and the other condition is exactly opposite to this. There you have a phasor diagram as VA1 making an angle 135 degrees and VA2 making an angle 45 degrees. This is exactly opposite to the previous case. And now, from this figure, this indicates VA1 and this indicates VA2. And let us consider only the linear part. And this part indicates resonance where VA1 and VA2 are equal. Let this be the resonant frequency. And this range is called peak separation range. If the frequency is in between this peak separation range, we will have linear variation. Peak separation range should be more than twice frequency deviation. Frequency deviation is nothing but delta f. And here, a disadvantage here is any variation in amplitude of input due to noise modifies the discriminator. So undesired frequency components corresponding to amplitude variations are produced in the detector output and the output gets distorted. So here, in order to prevent the distorted output, here we can use a limited circuit. So due to the use of limited circuit, the arrangement might be complex. So in order to overcome this difficulty, we are now going to discuss about the next method, which is most widely used. This is last method of demodulating frequency modulated phase, which is ratio detector. It's an improvement of Foster-Seeler discriminator. Here only difference is polarity of this D2 diode has been reversed. And the other thing is voltage. So since the polarity got reversed, here voltage also got reversed. And the advantage of these two resistors are amplitude fluctuations which are present in case of Foster-Seeler method will be absent here. So it's an improvement of Foster-Seeler method. and as it doesn't respond to amplitude fluctuations, you don't require any limiter circuit here. So due to the absence of limiter circuit, the design of this will be simple. And so here, only difference between previous method and this is the output voltage is half of the voltage what we have got in case of fast oscillator method. So output voltage VR is mod of VO1 plus mod of VO2, which is equal to, and this can also be written as V out is equal to V across T1 and T2. Since output voltage is measured across T1 and T2, output voltage is equal to VO2 minus VR by 2. Since resistance got halved here, voltage also gets halved. So output voltage is equal to VO2 minus VR by 2. Since we know that VR is equal to average of VO1 and VO2, finally we get output voltage is equal to VO2 minus VO1 plus VO2 by 2. This is obtained from this equation. So finally V out is equal to VO2 minus VO1 by 2. So only difference what we observe here is, in case of fast oscillator method, output voltage is VO2 minus VO1. But in case of ratio detector method, output voltage is VO2 minus VO1 by 2. But the advantage here is we don't require any limiter circuit and it doesn't respond to amplitude fluctuations.